After completing Section 7.3, you should be able to check validity conditions to use a t-distribution to analyze paired data, calculate and interpret the standard error of the mean of differences, calculate and interpret a standardized statistic for paired data, interpret a p-value and write a conclusion for paired data, and then calculate and interpret a confidence interval for a mean of differences. The key ideas from this section are that we are using the t-distribution for a theory-based test of paired data, that the standard error formula for the sample mean differences is S sub d over the square root of n, that the t-statistic or standardized statistic is x bar d divided by that standard error of the mean of differences, that a theory-based confidence interval can be calculated by finding the observed mean of differences plus or minus a multiplier which is given times the standard error formula, and that the validity conditions are that the distribution of differences is symmetric and bell-shaped, or that there are at least 20 differences and those differences are not heavily skewed. Let's use the M&M example from Section 7.3 to assess these learning outcomes. In this M&M example, an investigator studied whether bowl size would affect how much people eat, and answered this question by having college students participate in the study over several days. At one session, the 17 participants were assigned to receive either a small or large bowl at random, and were allowed to take as many M&Ms as possible. The following session, the bowl sizes were switched for each participant. What are the observational units from this study? The sample size is 17, and there are 17 participants, so the observational units are participants. How about the explanatory variable? In this case, the explanatory variable would be the size of the bowl that was assigned to the participant. The response variable here would be the number of M&Ms taken. Would you consider this design to be paired or independent? This is a paired design, specifically a paired design with repeated measures, because each participant is measured twice, at one session with a small bowl and at the other session with a large bowl. And would you consider this an experiment or an observational study? This is an experiment because they randomly assign the order of the bowl. The null hypothesis for the study is that the true mean difference in number of M&Ms taken is 0. And the alternative is that the true mean difference is less than 0 if we take the small bowl minus the large bowl. In other words, we expected people to take more M&Ms with the large bowl on average. Study. You see a plot of the differences for each individual on a dot plot with the summary statistics of the mean of differences being negative 10.88, again using small minus large as the order of subtraction. The sample size is 17, and the standard deviation of these differences is 36.3. Use this information to calculate the standard error and standardized statistic. Pause the video while you calculate these values, then play to see your answers. You should have gotten a standard error of the mean of differences of 8.804 with a standardized statistic of negative 1.24. Hopefully those are the values you got. Now pause the video and let's interpret these values. To interpret standard error, we would say that on average, each sample mean difference in number of M&Ms grabbed between the bowl sizes, small minus large, for an individual is 8.804 away from 0. And to interpret the standardized statistic, we would say that the observed mean of differences of negative 10.88 is 1.2 standard errors below the null value of 0. From the theory-based applet, we obtained a p-value of 0.1172. Interpret this number in the context of the problem, then write a conclusion. Pause the video while you do this, then play to see the correct interpretation and conclusion. We would expect to see an individual take at least 10.88 more M&Ms with a large bowl compared to a small bowl on average. That's our observed statistic of negative 10.88 and direction that the large bowl is larger than the small bowl number, or that the small bowl is less than the large bowl on average. In about 11.72% of samples, where we assume the null is true, each sample assumes the true mean difference in number of M&Ms taken between the large and small bowls is 0. We can conclude that there is weak evidence that the true number of M&Ms grabbed for an individual using a small bowl is less than the same individual using a large bowl on average. We could call this a causal relationship if the p-value had been small enough for those similar to the people, the 17 volunteers in our sample. Okay, now let's try a confidence interval. Pause the video while you calculate a 95% confidence interval for μ_d using 2.120 as the multiplier. How did you do? You should have gotten a confidence interval of negative 29.5 to 7.8. Notice that this interval contains 0, the null value. Is that what you expected? It should be, because we had a high p-value on the previous slide, indicating that we should fail to reject that null hypothesis, or that the null hypothesis that μ_d is equal to 0 is plausible. Not true, necessarily, but is a plausible explanation. Pause the video to interpret this interval, and then play to check your interpretation. Here are two examples of the correct way to interpret this interval. We are 95% confident that the true mean of the differences, the parameter, in context, in number of M&Ms taken between large and small bowls with order of subtraction, small minus large, is between negative 29.5 and 7.8 M&Ms. Alternatively, you could also state we are 95% confident that, on average, the true number of M&Ms taken with a large bowl is between 29.5 more and 7.8 less than with a small bowl for an individual. If you said we're 95% confident that the true mean number of M&Ms taken with a large bowl is 29.5 more to 7.8 less than with a small bowl, that would be incorrect. That is the example of an independent group's interpretation. And so we want to make sure that we're talking about a mean of differences, or that the difference for an individual is within this interval on average.